All right. Hi, everybody. Sorry about Wednesday. My computer decided that it didn't like the internet anymore, and it kept cutting out every 10 minutes. So I had to go back into the school, which is about an hour and a half away, and grab a computer from there, which will stay on the internet. So that was fun. Just a couple things to be ready for next week. We're going to do a mini project again next week. It'll take you 2 days. We'll give you all the instructions for that. Also, there is no Monday meetings next week because technically we all have the day off. So be outside, enjoy it, go for a bike ride, go for a hike, do something, get outside. With that out of the way, this lesson is going to be relatively quick, but hopefully it's going to be relatively useful. So the last lesson you did, the one where I give you a YouTube video, looked at how you find the distance between 2 points on a graph using the Pythagorean theorem. So you have, your grid, 2 points, and then you can use the grid to count up between the 2 points and use the Pythagorean theorem to figure out how far those points are apart. Today's lesson is going to be doing kind of the same idea, but now without the grid. So I'm giving you a word problem. You're going to pull some information out of the word problem and use that to find the length of your hypotenuse, or the distance between the 2 points that are given. All right. If you need a quick refresher, go back to the video that I gave you on Wednesday. Watch the first 3 minutes of that. That'll help you. And then cut back to this video here, and you should be all set. All right. So we're going to go present now, my entire screen, so you can see everything. I'm going to click on that, and I'm going to hit share because then you can see what's going on. Okay. So this is a problem written kind of like the ones that you have to submit to me later. Obviously different numbers, different ideas, but same idea, same principles going on. So it says, cell phone, radio, and windmill towers are all tall and thin. To hold them in place, engineers use large cables attached to the top of the tower. Then these cables are anchored to the ground a short distance from the tower. Just kind of give you an idea of what we're talking about. Here's a windmill. You'll notice that it's quite tall. If you've ever seen one up close in person, they're oftentimes hundreds of feet tall, and they're very narrow. The bases are surprisingly narrow. What that means is they're actually quite flexible, and they're not very stable. To make them more stable, sometimes engineers will put these cables, usually 3 of them, attached to the tower up relatively high and then anchored to the ground. These cables mean that if the wind wants to blow the windmill backwards, these front 2 cables will apply tension and keep it from falling over. If the windmill starts to fall forwards, this cable at the back right here will apply tension and stop it from moving. These 3 cables spread out the way they are, each one a third of the way around, prevents the windmill from going in any direction, keeps it right in place. All right. And our problem says, the cable is attached to the tower at 150 feet up and anchored to the ground 100 feet from the tower. How long is the cable? Okay, so let's pull out some useful information first. Try this new thing right here. All right. First thing, the cable is attached to the tower 150 feet up. All right, so 150 feet up. And pick another color right here. Anchored to the ground 100 feet away. Okay. And then what we're trying to find, obviously, is what is the length of this thing. All right. So useful information here, we're going to say 150 feet tall. And we're also going to say that since the cable is anchored 100 feet away from the tower, we're just going to say, lateral distance, left, right, whatever, however you want to put it, is 100 feet. So, or the length is 100 feet. And we're going after how tall the cable is. So without a grid, I'm just going to kind of do a sketch of this. You can do the same idea. They don't have to be exact at all because you're not going to actually be measuring them. You're going to be using them for calculations. So let's go here. Okay. Wrong color. There we go. All right, so our tower is 150 feet up, or 150 feet tall. So there's our tower. That's going to be 150. Okay. And it says right here that we're going 100 feet over. All right. And then our cable is going to be green and going to go right there. Okay. So there's our cable. And cable. Okay. One thing with the problems that I gave you, it asks what are the two legs that you're using. In this case, the first leg would be 150, and the second leg is 100 feet. It just says F. It should say feet. Okay. One thing to be aware of, it doesn't matter what order you pick. I could say that the first leg is 100 feet, or the distance from the tower, and the second leg is 150 feet, or the height of the tower. I could switch it either way. It doesn't matter as long as you recognize that these two spots here are the legs, and what we're looking for right here is the hypotenuse, or our answer. Okay. Moving on, we're going to go our Pythagorean theorem, which is a squared plus b squared equals c squared. All right. And we're going to say our a is 150. So 150 squared plus b, which is going to be 100 squared. That is going to equal, c squared. Okay. 150 times 150 is 22,500. We're going to add 100 squared, which is 100 times 100. And that's going to be 10,000. That's going to equal 32,500. Just enough space, kind of. All right, 32,500. And that equals c squared. And since it equals c squared, we now have to take the square root to get to what actual c is. So square root of 32,500 equals, it's approximately 180.2. That right there is our answer. It's approximately 180.2. So the cable going from 150 feet up on the top of the tower down to being anchored 100 feet away from the tower at ground level is going to be 180.2 feet long. Okay. Go back here. I'm going to stop presenting so you just see me. All right. Like I said, this lesson is going to be kind of short. You don't have a huge amount to do. You've got 3 problems. When you go to tell me what the legs are, don't just give me the lengths. Say what they are in the context of the problem. So if we thinking back to what we just did, I would say that one of the legs is 150 feet, and that is the height of the tower. And the other leg, or the second leg, is 100 feet, and that is the distance away from the tower that the cable is anchored on the ground. And then my answer is 180.2 feet, and that is the length of the cable from the anchor point to the point where it's attached to the tower. If you have any questions, today I have office hours at noon. Shoot me an email if you have any other questions like that, but please come to office hours. That's where I can draw things and make them look a little better than me trying to send you an email and trying to describe all this stuff. So if there's nothing else, I guess I have to say have a great weekend. Be outside, stay safe, and eat something good. All right? Have a great day. Bye-bye.